Welcome back to a new video lecture, and in this lecture we discuss the estimation of septic tank. So this is your question. So here you can observe, prepare a detailed estimate of a septic tank with soak pit for 25 uses from the given drawing. So many details regarding the soak pit and the septic tank is given there. So while doing problem, you will get more clarity regarding what all those things are mentioned here. So please go through these details, that is regarding the construction parts of the septic tank and the soak pit is mentioned here. Okay. So this is your sketch. From this SketchUp, you have to calculate the final estimation for the septic tank. Okay. So here you can observe that this is your septic tank elevation, and this is the soak pit. Here you can observe, and this is the plan view, and this is the plan view of the soak pit. Okay, actually what is the purpose of this septic tank and what is the purpose of this soak pit? So here an inlet pipe is provided here. You can observe an inlet pipe is provided here. So the wastes from the both the liquid and the solid waste matters will come and deposit over the septic tank, and here a baffle wall is provided here such that it allows the liquid matter to flow easily through this pipe or this outlet to the soak pit. Okay, so the liquid matters will go through to the soak pit and it will settle down and it will move on to the air surface. Okay, so that is the case of this septic tank and the soak pit, and here this is the diagram of plan view. Okay, and here the first class brickwork is constructed here with a different thickness, here 30 and here it is given as 20. So this is the case. Okay, so for easiness or for get a clear cut idea, we move on to the three-dimensional SketchUp. So here you can note down that the initial stage you have to excavate the soil and you have to construct this septic tank in this format. Okay, and here you can see the soak pit is also constructed in this format with some dimensions or some diameters, and here also some length, breadth and heights are provided. Okay, and after that you have to dig once again to the inner surface with some diameters that we'll check in the question. Okay, some inner diameters. Then a slab is provided over the or under the septic tank, and this is the another case of this slab, that a sloping surface is also provided over the septic tank. Okay, so over this is the first slab and this is the sloping surface is also provided. Okay, fine. And here you can observe that the septic tank is constructed with the first class brickwork up to some height and again up to some height with a different thickness you can see. Okay, so the bottom layer is the slab, then a sloping slab is provided there, then the first class brick, then again the first class brick. Both the thickness are different. Then here you can observe a baffle wall is provided here, and it is actually inserted into this first class brickwork. Okay, such that it will be placed very smoothly. Okay, then here you can observe stone wire pipes are or inlet and outlet pipes are provided here, this one, and here you can observe the pipes are provided here, and it is closed with the RCC slab. Okay, so that is mentioned here. This is a slab. RCC slab is provided here. And then coming to the soak pit, the bottom layer is constructed in this way with the diameter, and here the coarse aggregates are provided here, and this is the diagram to represent the dry brickwork. Okay, dry brickwork is provided here, and it is again coated with another layer of brick aggregate. Then it is closed with this. This is our first cylinder, dry brickwork. Then again it is closed with another. All these are cylinders actually. Okay, so then again it is closed with the coarse sand. This is another layer. So 3 layers of cylinders are placed over there. Okay, so while estimating, you have to calculate that 3 cases. Okay, 3 cylinders. Okay, so this is your final figure. Okay, and it is also closed here. So now we move on to the calculation of earthwork excavation for the septic tank. So here you can clearly observe that this dimension is going to be 200, and here it is mentioned 40. So this 40 is going throughout this portion. So total dimension is going to be 280 centimeter. Okay, the length is going to be 280 centimeter or 2.8 meter here mentioned. And if you observe here, this dimension is going to be 90. And what about the outer dimension? It is going to be 40. So 90 plus 40 plus here also 40 is there. So you have to add that 40 also. So you will get 170 or 1.7 meter. Then coming to the height, if you observe, here it is mentioned 20. Then here it is mentioned 140. Then a 30 is also mentioned. Then you have to consider this sloping surface, that is, you have to take the average, that is 0 plus 10 by 2, you will get 5 centimeter. So if you convert into meters, you will get 0.05, and if you add up the total height, it is going to be 1.95 meter. And the next procedure is very simple. You have to multiply this value is 1.95, then 1.7, then 2.8. You will get the earthwork excavation value. So here you can observe some more clarity, the 3-dimensional view, that is 1.95, 1.7, then 2.8 meters. And here you can observe that the septic tank value is going to be 2.8, 1.7, 1.95, and if you multiply, you will get 9.28 meter cube. Okay. Now we move on to the next case to calculate the earthwork excavation of the sock pit. For that, you have to consider the diameters. So here you can easily observe that this diameter is going to be, in the inside diameter, it is going to be 100 centimeter. It's clearly mentioned. Okay. Then this portion, this dry glass brickwork, both sides you are placing, so it is going to be 20 centimeters. So now it is going to be 100 plus 20 plus 20. Then here it is 15, and here also it is 15, here also 15, here also 15. So total 30 plus 30. So if you add up these values, 140, then 60, 200 centimeters, that is 2 meters. The diameter is going to be 2 meters. Or you can observe from the plan view of the sock pit. Okay, so that is a case of this sock pit upper portion. And when you are moving on to the lower portion, the value is going to be 100. Then you have to take this both the values, that is 100 plus 20 plus 20, you will get 140, and it is going to be 1.4 meter. It is clearly mentioned here also. So with the help of those values, you can calculate the earthwork excavation for the septic tank. And one more thing you have to observe, that the height of this lower portion is going to be 0.2 meter, and the height of the topmost portion is going to be 2.5 or 250 plus this 50, you will get 3 meter or 300 centimeters. So this is the 3-dimensional view. So now you move on to the sock pit up to 3 meter depth. You can clearly see that the area, that is pi d square by 4 multiplied by the height, you get 9.42. And the sock pit below lower portion is going to be 5 multiplied by d square, it is going to be 1.4 square by 4, and the height it is only 0.2. You will get 0.3, and after that you have to add up all those values. You will get 19 meter cube. Okay. Now moving on to the slab portion or the plain cement concrete portion, how to calculate. So if you observe here, you can clearly see that the total length of the slab, it is going to be 2.8 meter. Okay, that is 200 plus this 40 to the both the sides, so you will get 2.8. Then the width is going to be 1.7, that is 90 plus the 40 to both the sides. Okay, 1.7. Then the thickness, it is going to be 20 centimeter or 0.2 meter. Okay, so that is a case of the slab. Then the sloping portion, if you check out, its length, it is going to be this 200 centimeter or 2 meter. Inside portion only, slab, it is going to be the sloping surface, it is going to be 2 meter only, and the height, it is going to be, how to take the average, that is 0 plus 10 by 2, you will get 5 centimeter. And the width, it is going to be 90 centimeter. So with those values, you can clearly, this is the 3-dimensional view, and you can easily substitute those values. You will get this 2.8, 1.7, 0.2, and 2 meters, 0.9 width, then 0.05 meters. Everything is mentioned in meters. Okay. Now coming on to the first class brickwork. If you clearly observe, you can see that this is first case, then this is the second case. So first we observe this colored portion, this first class brick. Its height, it is going to be 0.6 meter, and the length, it is going to be 2.6 meters. Here you are considering 10 centimeters from both the sides. You have to remove that 10 centimeters since this construction is started after leaving a 10 centimeter from both the sides. So the total length, it is going to be 2.6 meter. Then the thickness, it is going to be 0.3, and the height, it is going to be 0.6. This yellow portion represents the long wall. Okay, so 2 numbers of long walls for this case. Then coming to the short wall, you can observe that the dimension is going to be 0.9. From this you can easily observe. Then height remains same, that is 0.6 itself. Then the thickness also remains same, that is 0.3 or 30 centimeter. So with these values, you can clearly mark. This is the 3-dimensional representations, which will give more clarity regarding those values. So if you observe here, you can see that first of all, the long walls, the first step you have to check out, that is the total numbers, it is going to be 2, the length, it is going to be 2.6, then the breadth, it is going to be 0.3, and the height, it is going to be 0.6. If you multiply, you will get this value. Then coming to the second, that is the short wall, the numbers is going to be 2, the length, it is going to be 0.9, the thickness, it is going to be 0.3, and the height, it is going to be 0.6. So you will get this value, 0.32. Now coming to the next case, that is the 20 centimeter thickness first class brickwork, that is the green portion shaded region. So if you observe, the thickness, it is going to be only 0.2 or 0.20 centimeter. The height you have to calculate, that is 1.15. How you got that 1.15? The total height you already obtained from the first calculation, that is 1.95 meter. So 1.95 meter minus this 60 and this 20. So you will get, that is 0.8. So if you subtract this 1.95 minus 0.8, you will get 1.15. So the height for the first class brick with this 20 centimeter thickness, it is going to be 1.15. Here also you can observe two long walls here. Okay, and the distance or the length, it is going to be 2.4, since here also a 10 centimeter is reduced both the sides. So the length, it is going to be 2.4 and the breadth, it is going to be 0.2. Then the height, it is going to be 1.5 for the long walls. Then the shorter walls, you can observe that the length, it is going to be 0.9 and the thickness, it is going to be 0.2 and the height, it is going to be 1.15. So this is the diagram, you can easily observe. So here it is mentioned that the second step represents that values, that is 2, 2.4, likewise all the values are mentioned here. Okay, now moving on to the next case, that is a second class brickwork in sock pit. Okay, so these portions, the topmost portion and the lower portion, is constructed using the second class brickwork. So our aim is to calculate the total estimation for that particular sections. For that, you have to consider the center line length of this particular case, center line length of this particular dimension. Okay, so actually the inner diameter, it is going to be 100 centimeter, and to both the sides the thickness, it is going to be 20 centimeter. Okay, so you have to take this 100 centimeter or this 1 meter plus 0.1 to this side and the 0.1 to this side. So you will get 1.2 meter. Okay, then you have to take the perimeter of that center line. So with this diagram, you will get more clarity. This second class brick is considered here. This yellow portion represents the second class brick. So the topmost portion and the lower portion you have to consider. For that, you are considering the center line length, that is 0.1 plus 1 plus 0.1, you will get 1.2 meter. Okay, the center line length you have to take. Then the height, it is given as 50 centimeter for this case, and here the height, it is given as 20 centimeter. So this is the case. So you got some idea regarding the three-dimensional figures. So the upper portion, the perimeter is going to be 5 multiplied by 1.2. Then the breadth is, it is given as 0.2 or 20 centimeter thickness. Then height, it is mentioned as 0.5 or 50 centimeter. Then the lower portion, the thickness, it is provided as 0.2, and also height, it is mentioned as 0.2. Then total values, if you multiply, you will get 0.5 meter cube. Okay, now moving on to the next case, that is the second class dry brickwork in sock pit, that is the inside portion. Okay, that is the inside cylinder, the first cylinder you have to consider, first cylinder. So here also the center line length you have to calculate. Then the same procedure again we are going to calculate. So if you observe here, this green lines is represent, or green color represents the inner portion of the first second dry brickwork. So we have to calculate that value. So the value, it is going to be again 1.2 itself. The height, it is going to be 250 centimeter or 2.5. So that is only difference. So if you observe, you will get this value, that is the length. You are going to take the perimeter actually. Okay, this perimeter value actually you are going to take 5 multiplied by the 1.2. Then breadth, it is going to 0.2, height, it is going to 2.5. Then coming to the next case, this RCC work. Actually, these RCC works are provided over this baffle wall, then the topmost portion of the septic tank, and this topmost portion of the sock pit. So for finding out the values, The slab for the RCC slab value, it is going to be, the thickness it is provided in this question, it is mentioned as 7.5 centimeter. Here it is mentioned 7.5 centimeter, that is 0.075. Then the length it is going to be 2.4. Okay, actually this much value, this 200 plus this much portions only we are going to covering. Okay, that is 2.4. So that is the case, and the breadth it is going to be 90 plus 20 and 20. So 90 plus 20 plus 20, you will get 130 centimeter or 1.3 meter. So that is the case for the RCC slab for the covering of the septic tank. Then coming to the soak pit, you can clearly observe that this value, that is the topmost portion, you have to cover. The value will be 100 plus this value, it is going to be 20 and again 20, so you will get 140 centimeter. Then here you can observe the baffle wall, and its dimension or its height, it is going to be 15 plus 30, that is 45 centimeter height, and the thickness it is provided as 4 centimeter. Okay, and it is provided here this 90 plus some 5 centimeter to both the sides, such that it will be placed very safely. Okay, so 90 plus 5 plus 5, you will get 100 centimeter. So that is the case. So from this three-dimensional diagram, you will get some more clarity regarding those values. The covering portion of the septic tank, that is thickness, is mentioned in the question, that is 7.5 centimeter. And the length you will get 2.4, and the thickness, width it is going to be 1.3. So this is the baffle wall, that is height it is going to be 30 plus 15 mentioned in the question, that is 45 centimeter. Thickness, it is provided 0.04 or 4 centimeter. Then the length it is going to be 90 plus 5 plus 5, 100 centimeter or 1 meter. This is the case for covering of soak pit, 1.4 diameter, and the thickness also provided in the question, that is 7.5 centimeter or 0.075 centimeter. So this the final, you can substitute those values, you will get roof cover slab for septic tank 2.4 multiplied by 1.3 multiplied by 0.075, you will get this value. Okay, then coming to the roof cover slab, you will get the value as pi d square by 4. You will get the area, then the thickness, then you will get this value. Then the baffle wall, the dimensions 1 meter, then breadth it is going to be 0.04, you will get this value. Then coming to the next case, that is regarding the plastering work. The plastering work you have to do over the inside portion and also the bottom surface. So from this diagram, you can clearly observe that the length it is going to be 2 meter, height is going to be 1.7, that you have to reduce, that is 1.7 you will get by reducing the slab height and also the sloping surface, you will get those values is 1.7. Okay, then so from this you can clearly observe that the 12 mm cement plaster, that is 1:3 cement standard waterproofing component septic tank, long walls, the length it is mentioned as 2 meters, and the plastering work to be in meter square. Okay, the value to be in meter square, so 2 multiplied by 1.7, and this long walls it is going to be 2. Okay, so if you observe from this diagram clearly, it is 2 long walls are here. This one is one long wall and this is another long wall, and the short wall it is going to be 0.9 multiplied by 1.7. Okay, so you'll get 3.06, and if you add up those values, you'll get 9.86 meter square. And the last calculation for the cement plaster over the bottom surface and the thickness to be provided is 20 mm. This 20 mm and this 12 mm has no influence over the estimation part. The calculation will be purely based on the area, meter square meter area. Okay, meter square. The length it is going to be 2 meter and the breadth it is going to be 0.9. So it is also clearly visible. The bottom portion dimension is going to be length it is going to be 2 meter and the 0.9. Okay. So you'll get 1.8 meter square. Then coming to the cases of brick aggregate, the various portions or various estimation you have to calculate the brick aggregate. So here you can easily observe that where actually the brick aggregates are placed. The second cylinder now you are going to analyze, that is this yellow portion, and here also brick aggregates are provided. So this area also you have to consider. So if you analyze here, you can observe that the center line length it is going to be 100 plus 20 plus 20. So you'll get 100 plus 20 plus 20, 140 up to here. Okay. Then the 15 centimeter from both the sides. So you have to take the only half portion. So 15. So you'll get 155 or 1.5 centimeter. And inside dimension it is going to be 100 centimeter. Okay. And the thickness it is going to be here it is 15 and here it is going to be the 20. The values are clearly mentioned here. If you observe clearly the brick aggregate values, you can clearly observe from this three-dimensional diagram. Okay. While calculating this cylindrical portion or this aggregate portion, central line length you have to take. Okay. The total length actually you have to take. Okay. So the outer side of sock pit it is going to be pi multiplied by the diameter or center line length. Then the breadth 0.15, height 2.5, and here also you can observe here you are going to take the directly area and multiplied by this height 0.2, and finally you will get 2 meter cube. And the next cylindrical portion now you are going to analyze, that is the coarse sand. Okay, that is the third cylinder. So here the blue color represents that coarse sand, and for that also you have to take the dimension. So if you observe inside 100, then 20 plus 20, then 15 plus 15, then again both the sides is 15 and here also 15, you have to take the half. So if you add up those values you will get 185 or 1.85 meter. Height it is going to be same 2.5. So if you calculate those values, you will get the coarse sand outer side sock pit it is going to be pi multiplied by 1.85 multiplied by 0.15, 2.5, you will get 2.18 meter cube. Then moving on to the next case, that is iron footsteps. So from this diagram you can clearly observe these footsteps are provided for if we have to clean up this septic tank, we are providing these footsteps. So 1, 2, 3, 4 likewise. So 4 numbers actually there. Okay. So if you observe here, the numbers it is going to be 4. Then the 100 mm dia stoneware pipe laying and joining with 1:3 cement mortar, complete inlet and from latrine to septic tank. It is also mentioned in the question clearly. It is also mentioned this 3 meter from the here it is already mentioned, that is 300 centimeter long. It is provided. So 3 meters. Then outer end from septic tank to sock pit, that is also mentioned here. So outer, it is already mentioned that it is 300 centimeter. Then you can easily add up these values. The length you can take as this 30 centimeter, or you can take the length it is going to be 3.3 meter. Okay. The outer end from outer end from septic tank to sock pit, the length from from here to this side. So you will get 3.3. You can take 3.3. So these pipes are already mentioned in the question, clearly shown the diagram, shown where T junction 100 mm dia with one leg of 40 centimeter. So if you observe this T junction, so that the number is, it is going to be 1. Then second 14th number, it is going to be bent. It is also mentioned here. This one is going to be the bent pipe. So the number, it is going to be 1 again. Then the 50 mm dias ventilating pipe. Here it is mentioned that 50 mm dia and its length, it is going to be 2 mm provided here. So you can write down that value, 2 mm. And 50 mm dia, see, at the top of ventilating pipe, it is also mentioned here, this top portion. Okay, so this top portion you can take down. So this is another case. This values, this is T junction, this is the bend case. Okay, you can simply write down how many numbers. Okay, so these are the details regarding the estimation of a septic tank and the soak pit. So if you get a drawing like this way of a plan or regarding this soak pit and septic tank, you can easily calculate the estimate of constructing a septic tank for your building. So I hope the section is clear, and with this we wind up today's section. Thank you.